Theorem 6 is the triangle inequality. Again, triangle inequality we had seen in one of the previous videos. So, triangle inequality states the following. So, triangle inequality states that the magnitude of the sum of two vectors would be less than or equal to the sum of their individual magnitudes. So, let us look at its proof again. Remember that there was an exercise which we solved earlier, for which one of the parts was trying to prove this triangle inequality. But for the sake of completeness of this series, in which we are looking at the proofs of the theorems given in this book, so let us prove it over here once again, just to recapitulate and just to continue in this series properly. So we will look at the proof of triangle inequality. This is exercise 1.3.4. So this question says that prove the triangle inequality so we are supposed to prove the triangle inequality, and they have provided some hints and some steps that we could use. So starting with mod squared of v plus w. So some more hints and steps are provided. You must use I'm losing out space over here, so we will write it here. You must use and the Schwarz inequality. The next part is show that the final inequality becomes an equality only if v is equal to a times w, where a is a real positive scalar. So this is the question. Just to remind ourselves what the Schwarz and triangle inequalities are, we will write it again. So the Schwarz inequality is given by the following expression. And the triangle inequality, the one that we have to prove in this question, so these are the two inequalities that we saw in the previous video, and we are supposed to prove the triangle inequality in this question. So the steps that are provided, or the hints that are provided in this question, says that we must use the Schwarz inequality in order to prove the triangle inequality. Now we will prove the Schwarz inequality separately in another video. This video is focusing on the triangle inequality. Also, we see that we are supposed to use this identity. This identity says that the real part of the inner product between the vectors v and w will be less than or equal to in magnitude of the magnitude of the inner product. So the real part is less than equal to the magnitude of the inner product. So we are supposed to use these two identities in order to prove the triangle inequality. So let us start proving this inequality and solving this question. So we start with this v plus w mod squared. Now by definition of the inner product, this is nothing but the inner product of v plus w. Now we can use we can open up this. So we can open it up as follows. So before that I can write down one step. So this is basically this plus this, and further we can open it up as follows. So this we have just expanded this mod squared of v plus w in such a format. This comes from the definition of inner product, how inner product works. So with inner products there is this axiom. So I will just write down the axiom over here. So there is this axiom for inner products. So this is the axiom for inner products, which basically shows the linearity in gets. So using this axiom, we have expanded this inner product over here in this step. So let us proceed. This first term out here is nothing but mod of v squared. Then we have inner product of v and w. And this last term is again mod of w squared. So let us rearrange a few terms. Now this right here is nothing but this, the conjugate. So how we got this? This is another axiom. So this is also axiom. So axiom for inner products, which states this, that w projected on v is the complex conjugate of v projected on w. So this is skew symmetric. This is the property of skew symmetry. So this is another axiom. Using this axiom, you will get this. Now let us proceed. what do we have? We have now this, if you see, it is a number. This inner product gives you a number plus the complex conjugate of the number. This is nothing but 2 times the real part of that number. So I repeat, so if we have a number, let's say some number z, and if we add the complex conjugate to it, then this is nothing but 2 times the real part of z. And it is easy to see this. We can see, let us say z equal to a plus I times some b, then z star equal to a minus I times b. So clearly z plus z star is 2 times a, which is 2 times real part of z. So using this, we get this statement. So let us continue further. Now see, we will use this given identity which says that the real part of the inner product between two vectors v and w is less than or equal to in magnitude of the inner product of the vectors. So real part is less than the magnitude. So we will use this identity over here when we write down the following. Let us first rewrite the above statement. Now we will use that inequality. So this will be less than equal to mod v squared plus mod w squared plus 2 times mod of vw. So how do we get this? We get this from the identity that we were already given in the question. So from this identity we get this line. Now here we will use the Schwarz inequality. So from the Schwarz inequality, we have the following. So now applying the Schwarz inequality, we get now this is nothing but mod of v plus mod of w whole squared, or this right over here, mod v squared plus mod w squared plus 2 mod v mod w. So finally what we have is and then taking square root on both sides, we get our triangle inequality. So we finally prove the triangle inequality as follows, and we have obtained the result that we wanted. Just before proceeding, this was an identity that we used. This is the Schwarz inequality. So the Schwarz inequality we will prove in another video, but before that, this was the Schwarz inequality, pardon me. So this is the Schwarz inequality which we will prove in another video, but this was an identity that we were given in the question, and we used this identity to basically derive or prove the triangle inequality. So now we will try to see this identity, this inequality, and try to prove this inequality. So let me write down that inequality once again. So this is not a part of the question. The question assumes that we know this inequality. So this inequality says so this is the inequality. Now clearly you see that the real part will be less than or equal to the magnitude. Why so? Because let us this is just some number, so let us assume that this is some number z. So z can be written as some real part plus the imaginary part. So z is a number, we split it up into the real and imaginary parts, and then the magnitude of this z will be nothing but square root of a squared plus b squared Now clearly we see that the real part of z is equal to a, and a will be less than or equal to a squared plus b squared. The equality over here will happen only when b equal to 0. So when b equal to 0, we get a is equal to square root of a squared, which is equal to a. So we see that real part of z is less than or equal to the magnitude of z. So this is an inequality. We see it very simply that this inequality is indeed true. So we have proved even this inequality that we were given in the question. Let us look at the next part. So we have completed the first part, which said prove the triangle inequality by using the Schwarz inequality and this particular identity. Next it says show that the final inequality becomes an inequality only if v is equal to a times w, where a is a real positive scalar. Now we saw this, we did this even in the previous video, in the previous problem, but we will do it over here as well for the sake of completeness. So the next part says that if we have v is equal to a times w, then the triangle inequality, then for this case in the triangle inequality reduces to an equality. So let us see our triangle inequality states the following. Now we are given that v is a scalar multiple of w and a is a positive real scalar. So let us start from the left hand side. Sorry, v is a times w, so this is the left hand side of the inequality. Then for the right hand side we have Now note that we have this is the left hand side, this is the right hand side, and note that the question clearly stated that a is a real positive scalar. And if you see over here, then we also see that mod of a plus 1 will be equal to mod of a plus 1 only for positive real a, because if a is something negative, then here this equality will not be satisfied. So for example, a is minus 5, then this left hand side will be 1 minus 5, which is 4, whereas the right hand side would be 1 plus 5, because we're taking the mod, which is 6, and clearly 4 will not be equal to 6. Similarly, if you take some complex numbers, so then taking the magnitude of the complex number added with 1 will be different than taking the magnitude of the complex number and then adding 1 to it. So this is true only for real positive a. So therefore we get so for real positive, this reduces to simply a plus 1, and we see that this equality is being satisfied in the triangle inequality for such a given case where v is a scalar multiple of w, a being a real positive scalar. So we have completed this question.